Next, we will determine the forces at point A. Recalling again that any force can be broken down into the sum of the forces in the x direction and the sum of the forces in the y direction. Thus, the reactive force at point A can be broken down to a force in the x direction of 0 pounds and a force in the y direction of 100 pounds. Similarly, the force along member AC can be broken down into the force along the x direction, which is unknown, and the force in the y direction, which is 0 pounds, since this member is horizontal. The force along member AB can be broken down into the force in the x direction, which is unknown, and the force in the y direction, which is also unknown. Since only one of the forces in the y direction is unknown, we will find the force ABY first. Recalling again that the sum of the forces in the y direction is 0, the force RAY, the force ACY, and the force ABY all equal 0. If we then substitute in the known values for the forces, we get 100 pounds plus 0 pounds plus the force ABY is equal to 0 pounds force. Thus, the force ABY is equal to negative 100 pounds. If you will recall, the reactive force at point A could be broken down into two components: the force in the x direction of 0 pounds and the force in the y direction of 100 pounds. Similarly, the force along member AC can be broken down into two components: an x component, which remains unknown, and a y component of 0 pounds. This 0 pounds is because member AC is completely horizontal. The force along member AB can also be broken down into an unknown x component and a known y component of minus 100 pounds. To find the force along member AB in the x direction, we sum the forces in the x direction to equal 0. Thus, the force ABX, the force ACX, and the force RAX must sum to 0. If we substitute in the known values for the forces, we find that the force ABX and the force ACX must equal 0 pounds, or the force ABX is equal to the opposite of the force ACX. At this point, we can go no further, so let's try another equation. Our next step is to determine the force ABX. Since we already know the force ABY, and we know that the tangent of the angle alpha is equal to the force ABY divided by the force ABX, we can substitute into the equation the tangent of 63.4 degrees is equal to minus 100 pounds divided by the force ABX. Isolating the force ABX and simplifying it, we find that the force ABX is negative 50 pounds. Next, we will find the force ACX, recalling the equation 33, where the force ABX is equal to the opposite of the force ACX. Substituting in the known value for ABX, we find that minus 50 pounds is equal to minus the force ACX. Thus, the force ACX is equal to 50 pounds. To apply a force in this direction, the member needs to be in tension. Our next step is to find the force along the member AB. We also know the force ABY from equation 8, so we can find the force AB using the sine of the angle alpha is equal to the force ABY divided by the force along the member AB. Substituting in the known values of alpha equals 63.4 degrees, the force ABY is equal to minus 100 pounds, we can determine that the force AB along the member is equal to negative 111.8 pounds. To apply the force in this direction, the member needs to be in compression. Next, we will find the force along member AC. Noting that the triangle is isosceles, we can use symmetry to determine that the force along CB is equal to 111.8 pounds in compression. We have now solved our truss problem. We have identified the forces in the two side members to be 111.8 pounds in compression, the force in the base to be 50 pounds in tension, and the three reactive forces have also been determined. The force RAY is 100 pounds, the force RCY is 100 pounds, and the force RCX is 0 pounds.